Drumlin Built, formerly Ankart Built, I rebranded this past year because no one could pronounce, let alone spell, Ankart. It's a Flemish name. Anyways, rebranded to Drumlin Built for no other reason than to make it easier to find. Located on the South Shore, so we work kind of from like Liverpool up to Chester and everywhere in between. We are always trying to adapt high efficiency, low carbon methods and products into all of our jobs. We don't strictly build passive house, net zero energy stuff. Maybe someday that would be something we could do, but for now it's just an aspect that we try to bring to any project that we take on. We did build our first net zero ready house in 2022, Soltaire designed house. It was a super fun project and learned a ton. Still waiting on our first net zero ready retrofit client. I just put that in there because we've primarily done renovations over the past few years, and living in a part of the world where our primary housing stock is over 100 years old. I'm really looking for the opportunity to put that into action. So I just put a note here that I am working through a deep-ish energy retrofit on my own 140-year-old house. I don't have the ability to kind of go full net zero on it, but as it did need quite a bit of exterior work when I bought it, it is a good opportunity. So we'll see how far I'm able to take it. So in 2020, me and two of my employees went down to Yestermorrow, which is in Vermont. It's a wonderful training school that does a whole range of kind of building programs and courses. We actually got a grant through the Nova Scotia government for training to do that. I don't remember the name of it right now, but if there's any builders out there that are interested, it's just kind of an education grant. And I just had to convince them that there was no one locally doing that education, and so they were able to fund us to go down, partially. Anyways, so it was definitely wonderful. So these were kind of like the main courses. The Intro to Building Science with Jacob Recusen. Essential Building Science is a book he wrote. Great book, especially if for builders and carpenters out there, or just anyone who kind of maybe doesn't have like an engineering or architecture background but wants like that great introduction. Very thorough, but still very easy to read. Green Rehab and Deep Energy Retrofits with Pete Yost. I just put in quotes here, wingnut testing, because if I have a little time later, I'll talk more about that. But he does this wonderful thing where basically he's just always kind of coming up with ideas to test and try out different methods and ideas, and I think it's really wonderful. As a builder, we often hear from makers of products and engineers and stuff about new methods and stuff, but we're always like, well, will that actually work? Like, will it stand up over time? And so he just kind of is like, well, let's test it, let's figure it out. So super inspiring. And then the last course, Super Installation for Zero Energy Homes with Bill Hustrunk. And this was my introduction to the kind of magic of cellulose insulation. I was always familiar with the product, but as probably most people in this area are, just as like a loose fill attic insulation, or as kind of blown in last resort into wall cavities without kind of taking care or much thought in it, just as kind of what is available. So anyways, very great course. There's my certificate from Yestermorrow. I didn't have a lot of images to use, so I just kind of went through my archives. Sorry. So, Dense Pack Cellulose. These are the reasons we like it. I say we, I mean me. My employees, I think, don't mind it, but I think they would probably rather not be the ones insulating the houses. They'd rather be, swinging the hammers and doing the nice, fun work with wood. But they don't mind it. So we like it because it's a recycled product, recycled newspaper, cardboard, with local production. So there is a production facility in Nova Scotia. I'm not sure exactly where it is. I think somewhere up in Truro.
Nova Scotia.
What?
Nova Scotia.
Yeah, near Truro. High carbon storing potential because it is, a paper product. There is, all that carbon taken out of the air. It's already served one use as a paper product through newsprint or I don't know, wherever else it comes from. And then it has a possibility of hopefully being locked away in a house for 100 or more years. and not being returned to the atmosphere in landfills or burned as energy, as some people think is a good idea. It's non-toxic, so the only coating that's on it, or most of the products is just borate, which is used to increase the thermal resistance as a fire retardant and to resist mold and rodents. The green fiber product, they just rebranded and switched it up that now their only product is an all borate solution.
Yes, so that's correct. So we took like a leadership step, I guess, in terms of North American manufacturers. We removed ammonium sulfate from the product.
Yes.
So all the cellulose that you find here now
Is all borate solutions. So before you had to specifically source a different product that they made, which just made it a little bit harder because it was like special order, whereas the product that they had wasn't an all borate solution, the kind of standard one. And then the last reason why I really like it as a renovator, as a remodeler, is it stops convection in walls if installed correctly. I think about this often because if we are working on a house and we don't have the opportunity to open up all the walls or to add exterior insulation, to maybe do like a really good job air sealing the house. If you get your Dense Pack Cellulose to the density necessary to be dense pack, so 3.5 to 4 pounds per cubic foot, and ideally at that point it's kind of filling all the cracks within the wall cavities and hopefully stopping the convection air inside the cavities themselves. It's also something that I think about. And again, this maybe comes back to like the wing nut testing, something that I maybe should set up a model for in my house somewhere or something. But I'm curious that the way we're building now, planning, for climate change and adding so many heat pumps and providing cooling to houses. And just as our cooling degree days increase in this province, but we're putting a lot of air barriers on the inside of our walls. I'm curious about if we still have the potential for convection within our cavities and bringing in moisture from outside that then, could condense on the inside. Anyways, just, something I would love engineers or building scientists to tell me that is not a problem, because that would rest my mind a little bit better. But I'm worried about it. This is in Vermont. They were just showing us also kind of how it burns. A lot of people, are worried about, because it is a paper product, that it might just like light fire. But especially at high density, it's basically wood at that point, and so it burns the same way as wood. It needs a lot of oxygen, and when you dense pack it, there isn't oxygen in there, so it just kind of chars. Yeah, it's not a petroleum product, so it's not going to fuel the fire. So how to do it, or how to get it right when you dense pack. So you make sure it's at the proper density, 3.5 to 4 pounds per cubic foot. And roughly when you look it up online, they claim R4 per inch. I don't know, maybe some people use less than that. But that's some of the numbers we see. Keep it vapor open, at least on one side. It has a great ability to absorb and spread moisture through it. So if you have a leak, a concentration of it, it will kind of disperse throughout the cellulose, but you want that moisture to be able to escape. So we always try to keep it vapor open on at least one side of the assembly. Use an all borate product, as I talked about. I just watch for static shock. I put this in here. We were just talking about this. We just had an issue when we were doing it in the very dry air of last winter, where we were like kind of seeing lightning like that in the attic, but we did find some solutions to it. Here's a photo of us starting the dense pack process at our build from last year. This was before we had finished fully strapping the walls, but we did strap them horizontally. I know there are ways to adhere the membranes to the wall so it's tight enough that it can resist the force of the dense packing, but we relied on the strapping to do that. You can see in the corner there how it's all strapped. This was in the winter, that's why everyone's wearing their winter stuff. Why we do it ourselves. So Because no one else will. Because every time I ask insulation contractors if they dense pack or if they could do it, they're like, well, probably. And that doesn't give me confidence. So, I want someone to say, yeah, we have done it. We can do it very well. So I can feel confident that we are reaching those density levels that we need and that it's going to be to the level of quality that we want. And because it became accessible to me through a generous benefactor, that's kind of a joke. It was just a gentleman I knew on the South Shore who was building himself a net zero house, just sort of as a pet project in a way. And he had the same issue where you couldn't find anyone to do it. And so he found a used machine for sale in Montreal, drove down and got it, refurbished it himself. And then I went and helped a little bit and was chatting with him about stuff and was like, well, what are you going to do with the machine when you're done with it? And he's like, I don't know. And I was like, okay, I'll buy it. So he sold it to me for a very good price because he had no plans to anyways. They are a proper dense packing machine is a lot more powerful than your kind of normal attic insulation machines you can rent at Kent, and they are quite expensive for someone who's not going to be using it, for jobs regularly. And because I'm a bit of a control freak, again, that goes back to because no one else will. I want to make sure it's done right, make sure that it's providing what we need it to provide in the walls. Here's a couple more photos from that job. So you can see in the attic, we did just do a loose fill up there. Our air barrier transferred from the outside into the ceiling. And yeah, we used the Suprema peel and stick on the outside of that house. It's a good product. But I think I mentioned this when I was here last time to the Suprema rep. It wasn't split back, the peel and stick. If anyone who's installed that stuff, they know it's a lot easier to install if you can pull half of the backing off at once. We weren't able to do that. It was made our lives very difficult. I think it was a manufacturing error because it did say it was a split back product. I will use it again as long as it is split in two. So yeah, I want to talk about wing nut testing. So Pete Yost did this DIY building science and product testing. And I just put, but really, how do we know? And so his idea is like, well, we do this a little bit on the job sites. If we're using a new product and we don't really trust it, we'll throw it in a puddle or stick it to, a piece of OSB outside and leave it there before we start using it for a while. He does this kind of on a longer term thing, and it's something I really want to start doing more kind of just in behind my shop. So, I put some questions here that I always have. Does fully adhered WRB really work as well installed vertically instead of horizontally? I don't know. I want to try it. Just set up a wall outside my house and leave it for a year. Can I trust reverse lap tape flashing? If we are doing a fully adhered WRB, but then we need to flash over top of that, is it trustworthy? I don't know. Let's try it. How long/well will aerosolized acrylic air sealing hold up? Yeah, I want to know. We got away from using acrylic caulking because it doesn't have the elasticity of some of the other stuff, and so I'm curious about now that we're sealing buildings with it, what's going to happen in the long term. So let's try it. This a totally other rant that I'm going to go on. Again, this is just me filling time. In this kind of world that we're in right now in building, where we're trying to build better, we're trying to build more efficient, but we're also really trying to build more because of the housing crisis that we have in North America. We're talking so much about panelization, and this again also goes back to kind of what we learned in Vermont, or what kind of inspired us down there. So yeah, panelization right now is really being pushed as a way of gaining sector efficiency. But I'm always curious, how does custom fit in? So how do custom houses, how do we make it, more affordable for one-offs and more efficient? But a great example of that is New Frameworks down in Vermont, which is a company owned by Jacob Rakusin, who wrote that book that I was mentioning. And they are just doing it themselves, full insulated panels with natural or carbon negative building insulation, so cellulose and straw primarily. They're a small company. I think they're less than 20, but they have rented and created a facility to do it themselves. So yeah, I'm really interested in incorporating panelization into small and medium construction companies. How do we kind of get to a point where, and hopefully Andrea's talk will shine some light on it for me, but like how do we kind of have a model where we can get a set of panel plans that we can then build, ourselves off-site and bring, maybe through January, February, and then bring to the job site in April when things are dry. And then beware of gimmicky solutions. So I put here, don't expect to 3D print your home anytime soon. I know you guys have all seen the funny giant CNC machines that are making houses that look like they're the poo emoji. But, I think those things, I think a lot of us see why that's not really realistic, but I also have concerns about kind of some other not less gimmicky, but still kind of pushed ideas. And one of them is SIPs. And this actually came up recently. I always try to kind of go online and learn and take part in discussions and stuff like this. And I was listening to this gentleman talk about, how to make efficiency, how to design for efficiency in ways that are like cost effective. And then at the end, he just was talking about how wonderful SIPs are. And he was talking about all these great studies. And then I just asked, I said, well, has there been any long-term studies of SIPs and their longevity and how they hold up? And he didn't really have an answer. And I said, because the reason is because we just built like a top hat on a SIP house because the roof had leaked. It was a flat roof. There was definitely some design problems with this house. But what was mostly the problem was how it was done. The roof leaked to a point where the SIP was no longer structural. So it was no longer viable to hold the snow load. And so we had to build an entire new roof structure on this house, transfer the roof load back onto the walls. We were there to help repair the overhangs on this SIP roof. I quoted, we were going to be there for a couple weeks. In the less than $50,000 range, it ended up being close to $200,000 building these. It was multiple new roofs on this whole system. So yeah, just these kind of like sort of gimmicky ideas. Maybe like here's this solution that's going to kind of work for everybody. Those things make me nervous a little bit, and so just beware a little bit. Anyway, that's it. Thank you.